Thanks everybody for showing up this morning. We're supposed to have a packed house. I think the rain has kind of deterred some folks. But we will hopefully have this presentation up on our website at some point. And so if any of your friends or colleagues weren't able to make it out here, just check our website and we should have that posted. Just real quick, I wanted to kind of update everyone on some things that have taken place since we adopted our ordinance back in February. We have updated our website thanks to Alan Harmon, the man behind the camera right over there. He did a great job with putting all the reference materials, all of our checklists, any material that's related to our new ordinance, you should be able to find on that website. And so that's been very beneficial. It's kind of organized us a little bit. We have updated our checklists, our commercial and single family checklists to reflect the new ordinance changes. And we have developed some guidance documents. Some of y'all are aware of the single family residential guidance document that we've put together. You can download a copy of that from our website. We're also working on a similar guidance document for small commercial redevelopment projects. We do see a lot of just your mom and pop small developments in Atlanta in these urban corridors that they don't have enough money to really hire the full-blown design team. So this is a way for us to kind of help out and give some ideas on ways that you can either retrofit your landscape island into a bioretention area or fit a tree well in your parking lot or things like that. So that should be out in the coming months. And we also have just updated our policies. In our ordinance, you can fall back on the water quality component if you're not able to provide the green infrastructure on your site. And so we have guidance on that. It can all be found on the website. And then just our tracking system, updating that. And so this is a picture of our website. It's got links to our past PowerPoint presentations and our YouTube videos of some of our past workshops. And also, we are planning, this is the first of a series of workshops really focusing in on design for engineers, landscape architects. We really do want to get as technical as possible in these conversations, just because these are new practices, primarily for the Southeast. A lot of these practices, as Ryan will touch on, have been around for many, many years, and there's been a lot of great research that's been done. And so we do want to focus in on specific practices in the future. So our upcoming workshops include next week, Susan and I are actually going to be presenting at StormCon up at Myrtle Beach, just kind of on the adoption of the ordinance, the processes, and just a little bit of technical background on all of that. In September, we're doing one on rainwater harvesting here in the South Face building. We've got some great speakers lined up for that. We'll hear some case studies on the Georgia Tech project, them using rainwater for flushing toilets. We also are going to be hearing from the Hyatt at Buckhead. They've installed a rainwater harvesting system to handle their cooling towers. And also in November, we're planning one on just vegetation and soil mixes. We're still looking for some presenters for that. So if anybody has any specialty in some of these different areas, let us know, and we'd love to have you come and present at one of these workshops. And then, well, either here, we haven't lined up the room yet. That one has not been actually, we haven't reserved the room yet, so we'll talk to Joy about that possibly. So, and then in December, we're going to have the folks from NC State and I believe a couple other specialists from around the country do a 2-day bioretention workshop, and that is going to be very in-depth. There is a fee associated with that one. If you need any more information, you can go on our website. I don't think we've posted the flyer just yet, but we're working on that. The City of Atlanta is hosting that, and NC State folks are coming down and presenting there. And so just very briefly, I want to go ahead and hand it over to Ryan in a second, but I just wanted to cover some of the information that we're going to be discussing this morning as it pertains to Georgia and Atlanta in our new ordinance. We have adopted the runoff reduction volume that's found in the Coastal Stormwater Supplement. That is our technical design manual for now. We're working on possibly, developing a Metro Atlanta design manual. We were just in a meeting a couple of days ago with ARC, and they're finally starting to say we're going to update the Blue Book to include some of these practices. It's in the very early stages of it, but it is moving forward. We're making do with the guidance documents that we have and the coastal supplement. So for now, those are our de facto design manuals, but that should be being updated soon. So the runoff reduction requirement is capturing that first 1 inch of rainfall that would drain off of impervious surfaces. I'm crazy here. And keeping it on the job site and either infiltrating it, reusing it, or sending it into a landscape island where it can be sucked up by the plants. And so the design manual gives you credits for providing green infrastructure on your system, so you can reduce the size of your detention system. And it also replaces the 1.2 inch water quality requirement. If you have a site where, based on the underlying soils or just the other constraints of the site, you just can't provide the entire 1 inch volume, and you provide us written rationale as to why and some data to back it up, then we'll let you fall back on the 1.2 inch water quality requirement. Okay. And so just real quick, these different categories, most of the projects that will meet these requirements are commercial redevelopment projects. And in Atlanta, there's very little new development where you're clearing woods and putting a new building. All of it's redevelopment. And so for projects that are less than 500 square feet of new or replaced impervious surface, there's no stormwater management required. Between 500 and 5,000 square feet, you only have to provide that 1 inch runoff reduction volume. And then anything, this thing is going crazy, anything above 5,000 square feet is your typical stormwater management plan with channel protection, rate reduction, and hydrology study. Again, we have our guidance document for a single-family development. Any new single-family home or large addition will need to provide that 1 inch volume requirement. And we have some practices, some 6 practices that are listed in this guidance document that have already been kind of pre-approved to work on those single-family lots. And we've also, I hope this doesn't do this the whole time. It's kind of jumping around. I think the battery might be low. And so we also have, in this book, it has tear-off detail sheets to where you can just tear it off and staple it to your plans and have a good idea of what you'll have on that individual lot. The concept plan meeting, this is for commercial projects only. For those categories you saw before, over 500 square feet of new impervious surface, we want to sit down with you and just kind of go over first the new ordinance, make sure the engineers and developers are aware of the new ordinance, the new requirements, and also just kind of just talk about some opportunities to use some of these different practices in their site plan. And so far this has worked really well. We've had over 100 meetings so far. Currently I've been doing these meetings just kind of for consistency's sake, but in the future, any of the site development reviewers will be able to hold one of these meetings. If you're downtown and want to just stop in, we should be able to take care of you. Okay. And just a brief overview of what we're going to be talking about today with Ron Winston. He's going to cover pervious pavement, which is basically an underlying drainage layer with an overlying permeable surface, okay? And based on our design manual, if you have less than 25 inches per hour infiltration of the subsoils, then an underdrain is required. And essentially, if you have an underdrain system, you can only get 50% of the volume credit in the void space underneath that system. If you have better soils, you get 100% of that void space. One of the new requirements for commercial development is providing infiltration testing up front during the design phase. And we've really seen some pretty decent infiltration rates. You'd be surprised at, I think the majority of our results have been B soils. So there are B soils in Atlanta. You just might have to break through that top layer of compacted red clay to get there. And so we really do require that those types of tests up front when you're putting those plans together. And for bioretention is another great practice that you can kind of fit in with some of these tighter sites. Bioretention is just a shallow depressed area with engineered soil mix, and then it's planted afterwards. And then if you need additional space, you can provide aggregate underneath that soil mix, and the ratios are listed below. The storage volume that you get credit for is the surface area multiplied by the ponding depth, which is typically about 9 inches in the system. So you get full credit for that ponding depth, and then you get the depth of the planting bed multiplied by the void ratio. That'll give you a total volume for that practice. Okay. And with that, hold on, let me grab something real quick. Going to introduce our speaker. Actually, we have a typical detail we're still working on for bioretention. This will be in our small commercial guidance document. You can see it has a raised underdrain on it, which is something that we like. This really, if you do have poorer soils, this will develop an internal storage system. I think Ryan will go into that a little bit more. But that's something that NC State has been doing a lot of research on, and it's something that we're looking to adopt as well. And with that, Mr. Ryan Winston is an extension and research engineer in the Biological and Agricultural Engineering Department of North Carolina State University. He works under the guidance of Dr. Bill Hunt, studying performance of innovative stormwater control measures. His primary research focus is performance of permeable pavement and bioretention in North Carolina and Ohio, with additional interest in highway states and highway runoff treatment. He has been involved in the design, installation, and monitoring of BMPs in 6 U.S. states. Ryan has authored or co-authored 14 peer-reviewed journal articles since 2010. He's involved with about 15 workshops and training events per year across North Carolina and the United States. Ryan received his undergraduate degree from the University of Florida in 2007. I didn't know that when I invited him here, but he's here, so. And his MS degree in 2009 at North Carolina State University. He is a registered professional engineer in North Carolina. Please welcome Ryan Winston.
Thanks, Corey. He got the best picture of me he could find on the internet. I am an avid hiker, and so that's me on the Appalachian Trail. And since I'm in Georgia, I can talk a little bit about the South Carolina governor. I was actually on the Appalachian Trail. I wasn't in Argentina with my mistress. I don't have a mistress. I'm not saying that. But yeah, I really appreciate the introduction. I am an extension and research engineer. I'm full-time up at NC State. Been there for about 6 years now. Doing a bunch of different research, some of which is bioretention and permeable pavement. Do you want me to do permeable pavement first or bioretention? Okay. I think I'm going to, if you guys don't mind, I'm going to do bioretention first, and then we'll do permeable pavement later on this afternoon. Yeah, we've been doing research for a number of years. We've got about 10 years of data, I would say, now on bioretention, and slightly more than that, nearly 15 years on permeable pavement, as you'll see. So I'll show you the good, the bad, the ugly, everything in between. I'll show you data, show you design and installation experience. So hopefully you'll be able to glean a lot of information that you'll find useful here in the city of Atlanta. So briefly, going back to maybe 3rd or 4th grade, right, the hydrologic cycle, we've got water coming down. And then, of course, as that hits the ground, we get surface runoff, and that's what we're really worried about with stormwater management. So when we pave, like we have the parking lot back over here, you drastically change that water cycle, right? You've got the vast majority of your water running off and down into your storm drain network. And so that's some of the things that we're trying to do to change with our low-impact development practices. So why do we care about stormwater management? The first one would be flooding, right? If that's your house, you're really in bad shape. So obviously threatens life and property. So especially with a lot of the tropical events that we get that have first names here in Georgia and in North Carolina for that matter. Increased stormwater volume, we're getting more runoff going through our streams, and so you get stream bank erosion. This is actually on our vet school campus up at NC State. I hate to admit that, but it is. And then you get just pollution, right? You get more pollutant load, you get more volume of runoff, and therefore you have more pollution coming off of your urban surfaces. So that impairs our water quality, hurts our fishing and shellfishing waters, etc. So there's a lot of reasons why we care about stormwater management. So our pace of construction has slowed substantially, right, in the past 5-6 years compared to 2006, 2007. So I think this is a really good time to go back and look at the way we develop. And obviously the City of Atlanta is doing that with the changes to their ordinances. And so we've got a chance here to really change our paradigm and what we do as far as development goes. So just a quick water budget for you. In pre-development conditions where you've got, let's say, a forest is typically what we'd have here in the southeast, you'd have a lot of canopy interception and just general depressional storage in your watershed. So you have very, very little runoff. 5% is very dependent on soil type, etc. But just bear with me, these are rough numbers. You get a majority of your water goes either back up into the air through evapotranspiration or back down into the ground through infiltration. And then you go ahead and you build your parking lot, your rooftop like we have here, and you change your hydrology substantially, right? You have a lot more impervious surfaces. And so what that leads to is greater generation of runoff. 55% again is a very, very rough number and is dependent on your density of your development, obviously. So what can we do to mitigate these increases in impervious surfaces? We can basically implement these stormwater control measures that we're going to talk about today. And bioretention and permeable pavement, I would say, are pretty much the standard bearers for low impact development, that and probably the green roof are the three big ones. And so in terms of flooding, we can detain the runoff and release it at a much slower rate, thereby reducing our stream bank erosion. We have increased volume obviously coming off of our impervious surfaces, and so we can retain some of that on site, and through filtering through media or by uptake through plants, we can reduce the volume that's going to our storm drain network. And then obviously we're treating a lot of that increased pollutant load again through filtration, sedimentation, other processes that are occurring in our stormwater practices. So low impact development principles really are a big shift from our typical pipe and pond mentality. If you look at this graph here, the red hydrograph is what we call it, flow versus time, is our pre-development, or our post-development without any BMPs at all, right? So we've increased, pre-development is here in green, so we've increased the amount of volume, or the area under that curve. We've increased the peak flow rate. There's more water essentially arriving faster. And if you implement a typical wet pond type situation, which is this sort of burnt orange Texas color here, University of Texas color, we match our peak flow rate, but you can see that peak flow rate extends for a very long period of time, and you might have outflow from that pond for 2, 3, 4, even 5 days. And so what that does is you're impacting your stream banks substantially with those higher flow rates over a longer period of time. So with LID principles, what we're really trying to do is match the entire hydrograph, the peak flow rate, the amount of volume that's leaving our site post-development. And you can see here, the picture in the bottom left didn't show up very well. I won't name where this is, but this is in a 2-hour radius from Atlanta. And you can see some of the old development styles that we had, where we had these concrete trapezoidal channels, and we have a roadway here that's given way, and this is kind of hard to see, but that's an 8-foot diameter culvert there that has been lost due to the amount of flow going through that system. So this is really what we're trying to avoid. All right, so a quick example of an LID site. This is a commercial site in downtown Raleigh where it's an old gas station, and they've redone it with Pervious pavement, a rain garden out front, a cistern there as well for water reuse, and then a green roof on the top of it. So very similar to what we've got here at this building. Very integrated use of BMPs on the site. So let's jump in and talk about bioretention now. Bioretention really is one of the best practices that you can use as far as both water quality and water quantity control as far as a green infrastructure practice goes. The reason for that is there's so many mechanisms for pollutant removal as well as infiltration into the underlying soil. So what we essentially have is surface ponding in what we term the bowl. We have an overflow structure typically, and then a specially designed media. We'll talk a lot about the media. And then we have a drainage layer that's typically rock or aggregate that is an envelope around an underdrain typically, perforated underdrain. So where can you find these systems? There's a number of places you can find them. This is an ultra-urban application at a mall in Charlotte where I had my computer stolen, unfortunately. So That's another story for another day. Huntersville residential applications. This is just outside of Charlotte. That's my dream house, I think. But you can see they've taken all of the roof leaders and put that into one outlet here with specialized media between in the driveway there to filter the runoff as it leaves the house. This is an application in New Zealand. This is my mother's home country.